let's see how we go from features of a hyperbola to its equation. In this case, the graph, the vertices, the foci, we know the links of the axes, really just any of the features. Remember, you have vertices, covertices, the conjugate axis, the transverse axis, which transverses, I don't think I mentioned that one before, so let me lay that one out. Here, this is the transverse axis. And this is the conjugate axis. But if we know first that what we are dealing with is a hyperbola, and we can measure or we know some of the features, then we can construct a model of that hyperbola mathematically, which is just the equation. And that's what we're going to do. So first, I need to know the orientation, the center, and the radius of the transverse axis and the conjugate axis in order to write the equation. Okay? So I'll write that down. We need to know the orientation. Does it open up and down, or does it open side to side? This hyperbola is opening to the left and right. So side to side, it's a horizontal parabola. So we're going to go horizontal. Which means that in the equation, x will come first, and then we will subtract y. So we will have x minus h squared over a squared minus y minus k squared over b squared equals 1. And then, once we've got the orientation and the standard form of the equation, all I really have to do from here is find h and k, my center, and then a and b, which are my horizontal radius and my vertical radius from the center of the rectangle. So that's what we'll do. First, we're going to go for the center. So I'm going to make room for that. Center's pretty easy. If this is my hyperbola, then all I have to do is look at the midpoint. Well, there it is, which they actually have the asymptotes in here as well. So I can see it's at -1, -1. So the center here is at -1, -1. Which, when that goes into my equation, using horizontal inside opposite and vertical also inside opposite for this. Everything inside is opposite. The -1 becomes +1. The -1 here becomes +1. Next, I'm going to go for A and B. Again, A and B are just arbitrary letters. What we really need to pay attention to is the radius in the direction. So this A under X is the horizontal radius. This B under Y is the vertical radius. So I'm going to count. For A, the thing that goes under X, from the center, I go 1, 2, 3, 4 units from the center. So A is 4. B, if I see this central rectangle here, I know I go from the center 1, 2, 3, 4 as well. 1, 2, 3, 4. Yeah, 4. Huh. So it is a central square, which means both of those on the bottom will be 16. which we're going to leave like that. We could simplify it to x plus 1 squared minus y plus 1 squared equals 16 because we have that common radius like a circle, but we're not. That's all we're looking for, is that standard form of the equation of a hyperbola, x minus h squared over a squared minus y minus k squared over b squared equals 1. Keep in mind, had the hyperbola been oriented vertically, the x and y would have switched, so we'd have y minus k squared minus x minus h squared over a squared and b squared. Okay. All right. Now, if they give me the graph, it's pretty easy. I just look. Well, there's a center, there's the radius to the horizontal, there's the radius to the vertical. So I've got that. What if instead of a nice picture, they give us a description of the hyperbola, some amount of information about its features. In this case, its vertices and its foci. Vertices at 7, 3 and 7, negative 5. Foci at 7, negative 1 plus root 97. And 7, negative 1 minus root 97. All right, well. Like all things, if I can draw a picture of it, I'm going to try to draw a picture of it. Especially these. Because the first thing I need to figure out is the orientation of the hyperbola. Is it vertical or is it horizontal? And the vertices will tell me that. I know the vertices are the endpoints of the transverse axis. And the transverse axis is the one that cuts through the hyperbola. So that's going to help me figure out that orientation very easily. So I sketched them. Don't have to be very detailed. 7, 3, I'm going to say is here. That's the point, 7, 3. And then 7, negative 5 has the exact same x value, but negative 5. It went down to negative 5. So I know that's about there. Which means that this particular hyperbola must open up and down. So I've got the orientation. I see that with the foci as well. 7 and negative 1 plus root 97 is up here. And 7 and negative 1 minus root 97 is right down there. Which, since we're already drawing, I might as well plot those two. There's one foci, that's 7 and negative 1 plus the square root of 97. And the other foci would be down here at 7 and negative 1 minus the square root of 97. Those are my foci. But what matters is that we've got the orientation now. We figured out that y is going to come first, so it's going to be y minus k squared minus x minus h squared over a squared over b squared equals 1. A and b don't go with y or x. It's just a comes first and b comes second in the alphabet. So we put an a here and a b there, but it's the horizontal radius that always goes under x. It's the vertical radius that always goes under y. So we're going to figure those out now. Well, we're not going to figure them out right now because we need the center first. All of these radius values are measured from the center of these conic sections. The circle, the ellipse, the hyperbola, even the parabola to some extent, although it gets a new name, focus and directrix. So we need to figure out what the center of this is. And luckily, I know that the center is dead in the middle of the vertices, of the foci, of the co-vertices. It is the center of everything. So if I know the ordered pairs for the vertices, then all I have to do is find the midpoint of this, which is going to be 7. And in the midpoint for 3 and negative 5 is negative 1. It's by adding them and finding the average. 3 plus negative 5 is negative 2. Divide that in half and you get negative 1. That is the midpoint of those coordinates. So now I have my center, H, Okay, be very careful. Y comes first. So it's y minus k, which we now know is -1. So we're going to put a +1 there. And x minus h, which we now know is 7. So we're going to put x minus 7 there. Now I got to find a and b, which for this particular hyperbola, a is going to be the easiest. Because that's a. It's 4. -1 to 3 is 4. So a is just going to be 4. A squared is going to be 16. That's pretty simple. B, though, B is going to be a little bit more challenging. It's my conjugate axis, which means it goes off in this direction. But I don't have anything in this information that directly relates to B. But I do know that in a hyperbola, a squared plus b squared is equal to c squared, which is that length to the foci. So I can use those focal points to find that. And I know what c is. They told it. It's plus root 97 minus root 97. C is the square root of 97. So I'm going to use that Pythagorean theorem to figure that out. So for instance, I know that a squared plus b squared is equal to c squared. So 16 plus b squared is equal to 97. B squared is equal to 81. Which is really all I need. That's what goes in the equation, b squared. B squared is 81. That does mean b is 9. But we've got what we came for. The b squared is 81. That's going to complete my equation. Y plus 1 squared over 16 minus x minus 7 squared over 81 equals 1 is going to create a hyperbola with vertices at these coordinates and foci at these coordinates, which is all we were looking for writing that equation. Okay. All right. I'll post one on parabolas, but we've already really done parabolas earlier in the year, so it'll be a refresher on the focus and directrix and figuring out the equation. That shouldn't be too hard. I'll hopefully get that up to tomorrow. And then sometime this week, Friday, Saturday, or Sunday, I will post the test on hyperbola and parabola, very much like the last test with circles and ellipses, where it'll be asking you, here's the equation, tell me some of the features, and again, probably heavily relying on multiple choice for the graphing aspect of it, matching the graph to the equation to the graph. Okay. So get those exercises done, and I'll post another video in the next few days.